Azure storage accounts serve as the foundational component for hosting diverse storage services, such as blob, file, queue, and table. They unify various storage services under a single management layer, offering consistent configuration, authentication, and billing. In the context of the AZ-104 certification, understanding storage account creation and configuration is essential when planning data storage strategies and ensuring efficient maintenance. These accounts integrate seamlessly with protection features, including virtual network rules and shared access signatures, which were explored in previous units. By carefully designing storage accounts, administrators can optimize data distribution, define secure endpoints, and align performance to workload demands while maintaining compliance requirements. Azure provides multiple storage account varieties tailored to different data and application needs. General-purpose V2 accounts are widely used, offering the latest features for blob, file, queue, and table storage. Although general-purpose V1 accounts are still supported, they lack advanced capabilities like hot and cool tiering. Other specialized types include blob storage for high performance, block-only storage, and file storage for premium file shares. Each type integrates with established security mechanisms, encompassing encryption and network filtering features discussed in previous lessons. Selecting the right account type depends on cost objectives, performance goals, and the nature of data that must be stored or processed. Azure storage accounts provide redundancy mechanisms to enhance data durability. Locally redundant storage, LRS, maintains 3 copies of data within a single region. Zone redundant storage, ZRS, spreads copies across different availability zones, offering greater protection against regional zone-level failures. Geo-redundant storage, GRS, replicates data to a secondary region, while read-access geo-redundant storage, RAGRS, enables read access during a regional outage. Balancing cost and fault tolerance is pivotal when choosing a redundancy model. For mission-critical applications, geo-redundancy ensures consistent availability, whereas smaller, budget-constrained workloads might favor local or zone-level replication to align with business continuity strategies. The performance tier determines throughput and latency for Azure storage. Standard tier uses hard disk-based storage, providing cost-effective, widely applicable performance. Premium tier employs solid-state drives, SSDs, and is suitable for workloads demanding high input-output operations per second, IOPS. When configuring an account, administrators evaluate performance requirements, including transaction frequency and latency sensitivity, to select an appropriate tier. For example, premium file shares support rapid data manipulation, essential for enterprise applications with real-time access requirements. Meanwhile, standard storage accounts offer balanced performance for less intensive scenarios. Aligning the right tier with the workload ensures optimal efficiency and cost savings. Access tiers in Azure Storage define how often data is accessed, helping organizations minimize costs. The hot tier, for frequently accessed data, applies to general-purpose V2 accounts. The cool tier, which is less expensive per gigabyte stored, is intended for less frequently accessed data. Finally, the archive tier involves offline storage with the lowest cost but the highest latency for data retrieval. Administrators can automate tier transitions based on usage patterns, ensuring data remains in the most appropriate tier to manage costs effectively. This tiering strategy complements earlier security and access configurations, providing both economic and operational efficiency. Azure storage accounts incorporate robust networking features to protect data from unauthorized access and minimize exposure. Administrators can restrict inbound traffic through Azure storage firewalls and virtual networks, building on the concepts previously studied in configuring storage firewalls and networking rules. Network connectivity settings also include private endpoints, which map the storage account to an IP address within a virtual network. This eliminates public exposure of data resources, ensuring higher security. Additionally, peered virtual networks can securely access storage without crossing the public internet. Through careful design, These features support compliance mandates and reduce risk while permitting legitimate client access. Azure Storage Encryption protects data at rest using EES 256 by default, ensuring compliance with stringent security standards. Administrators can opt to manage encryption keys themselves through Azure Key Vault, improving control and regulatory compliance. This approach also allows rotation and automated management of keys across diverse environments. Integration with other identity-based mechanisms, such as Azure Active Directory, builds on previous lessons involving secure access signatures and stored access policies. Encryption extends to both data at rest and in transit via HTTPS. By coordinating encryption and identity strategies, organizations assure data confidentiality and preserve audit readiness throughout the storage lifecycle. Monitoring a storage account's performance and security is a key responsibility for Azure administrators. Native tools such as Azure Monitor and Azure Storage Metrics enable comprehensive oversight. Administrators can track capacity usage, measure average latency, and analyze transaction volumes. They can also set up alerts to receive notifications when thresholds are exceeded or suspicious activities occur. Logs provide insight into operations, including file access, container creation, and network requests, helping administrators investigate issues. Seamless integration with services like Azure Monitor Logs and Log Analytics fosters advanced diagnostics, aligning with best practices for proactive management and data-driven decision-making. Administrators have multiple methods to create and configure storage accounts. The Azure portal offers a graphical interface for setting up account properties and selecting redundancy or performance tiers. Scripts in PowerShell or Azure CLI provide an automated approach for large-scale or repetitive tasks, aligning well with DevOps practices. For integration, ARM templates define infrastructure as code, ensuring repeatable deployments. For advanced orchestration, solutions like the Azure Resource Mover or templates integrated with GitHub Actions streamline complex workflows. These tools build upon earlier security and identity settings, providing consistent governance across multiple environments while maintaining agility. To implement and manage storage effectively, administrators adopt a systematic process that encompasses design, deployment, and maintenance. Design considerations include selecting the right type of storage account, redundancy level, and network configuration for security. During deployment, best practices involve ensuring encryption is enabled, applying fine-grained access via SAS tokens, and configuring firewalls or private endpoints. Maintenance extends to monitoring capacity and performance, automating backup strategies, and controlling expenditures by leveraging tiering. By aligning these practices with Azure's built-in security, organizations can maintain high availability while containing costs. Each element contributes to a fully integrated storage environment that meets evolving business needs.